Okay, so to illustrate what is what does distance traveled means, basically distance travel, or sometimes to be more explicit, total distance traveled. When we talk about that, it's really just adding up all the distances. So distance is really the absolute value. So ignoring the direction, we're just looking at magnitude, right? So it's simple when let's say you start from home and you go over here. So if you just have a straight line going from one point to another, all right, so that's the displacement. You need to talk, if it's in 2D, you need to talk about it in a vector. Let's call it S, right, like that. If you talk about distance, it's just the length of that vector. That's distance, right? So displacement versus distance. Now, however, so the total distance is the same, but let's say the motion is more complicated. Well, so if this is my initial point, so I'll call it I, right? And then I start to move from school to the grocery store, and then the grocery store, I start to go to meet some friends over here, and then I also go to a convenience store to pick up something like this. All right, so this is my whole journey, right? This is the path of my whole journey or my whole motion, right? So what is the displacement? Well, this is the final stop, right? So what is the displacement? Displacement is, well, I need to add up all the total displacement is me adding up all these vectors. So the total displacement is, let's call it capital S, right? Can't really tell, so let's specify it as total, right? It's just adding up all the little s like this. So this means summation. This is the Greek letter sigma, if you haven't seen that before. Sigma is sort of a Greek S, right? S for summation. So adding this all up, so let's call that S1, S2, S3, S4, like this. Okay, so this is just meaning S1, S2, S3, S4. And if you remember, I use the 3 strokes equal sign. It's called identical to. Right? So in math, this is called identical to. I could write equal, but it's just to emphasize that this is identical to this. Right? So this is what that means. So how do you add vectors? Well, you go from head to tail, and if I just add S1 and S2, this is my final vector, right? This is my resultant. If I add S1, S2, S3, well, I need to go from the initial point all the way to the final point. So this is my resultant vector. But if I add S1 plus S2 plus S3 plus S4, like what I want, then the final resultant displacement is this. So this is S total. Okay, so connect. Remember, how do you add vectors geometrically, right? So you add head to tail each time. So if I add all 4, the head is here, the tail is here, all the way to the end. So these are just to be clear, these are just little markers. So imagine I'm going, from home to school to a grocery store, meet some friends at a convenience store, or something like that. Okay, so that's the displacement vector. Whatever that is, you can add them algebraically if I have all the numbers for everything. And addition is very easy, component by component, especially in column form. It's up to you, whether in component form, row, or column, every way is the same. The distance is, well, what is the distance between initial and final? Well, it's just here, right? Whatever that distance is. So it's just the magnitude of that, okay? However, total, so let's say so when we say distance, usually that just means the magnitude of that, right? So that would be the distance from initial to final. However, the distance traveled, you see, is not this. The distance traveled is this. So now you see the distance traveled is not the magnitude of S total, it's not the length of S total, but the length of individually adding them up. And notice one thing here is if you add up the individual lengths, they do not necessarily equal. That's a not equal sign, it's curled. they are not equal to this. Okay. Remember the shorthand. Sometimes we just use we just not write the vector sign as a lazy way to write magnitudes, right? So you notice if these are vectors in 2 dimensions, S1 plus S2 plus S3 plus S4 does not equal the magnitude of S total. All right. So this works with scalars to some degree in 1 dimension, as we'll see, but not in 2 dimensions. Okay. So so this hopefully tells you the difference between all this, right? So just to as a summary, that's the displacement vector. Displacement is a vector. The distance between initial and final is this, and the distance traveled is you add up the magnitude of every little thing. Okay. Yeah. So also to clarify, displacement and this position is the position of position can be position of one thing. Displacement have to be displacement between 2 points. Let me say 1 point. You can have the position of 1 point. Distance is the distance between 2 points, and total distance can be 2 or more points. Okay, maybe that's another way to look at this. Okay, so we'll look at just in 1 dimension. Notice in 2 dimensions a little bit more complicated, so you won't get too much questions in 2 dimension other than understand this concept. But in 1 dimension, we'll see what is the things you need to know about that.